Hello, this is a video on mean, median, range, and mode. So what I'd like to do is start with some simple definitions of them. So let's start with mean. And the mean is the average. How do you get an average? You add up the numbers and you divide by the number of numbers. That's number one. Median is the middle number. Now, there are a couple of rules you need to know about the median. So let me give you a list of numbers. Let's say 2, 4, 5, and 2. So we have this short list. The very first thing you must do is put the numbers in numerical order, or you're going to mess it up. Because right now you would say, oh, well, the middle number is 4. But once you put it in numerical order, right, we have 1, 2, and then we have 2. And what you should do is cross off the numbers as you go. Then 4, and then 5. Now you can see that your median rather, is 2. And that is correct. Now, what if I change it? So instead of having an odd number of numbers in the list, I take 1 out and I have an even number of numbers in the list, right? I just got rid of a 2. Well, now there is no middle number. We have 2 middle numbers. So what we need to do is take the average of those 2 numbers to get the median. We add them up, we divide by the number of numbers, which is 2, we get 6/2 or 3. And so in this case, 3 is our median, even though it doesn't even exist in this list. Alrighty, now we have range. And range is simply the difference between the smallest and largest numbers. All right, so that just means you subtract the smallest from the largest number, and that will be your range. And finally, mode, and that is the number that pops up the most. Okay, mode sounds like most. That's how you can remember it. All right, so now that we have those basic definitions and rules intact, let's go to a couple of questions on the test. So I'm going to get rid of this here. And let's go to test 1, section 4, number 12. All right, and we have a bar graph, okay, or what they call a histogram. And we see on the x-axis, it's number of seeds. On the y-axis, it's number of apples. And the title on the top of that histogram is number of seeds in each of 12 apples. So our focus is on the seeds. Okay, so the first bar, it says there are 3 seeds. And if we go to the y-axis, there are 3 seeds in 2 apples. Now, as you can see, we don't have a list of numbers. And well, I guess I should read the question. Based on the histogram above, of the following, which is closest to the average, arithmetic mean, number of seeds per apple? So actually, I have a couple of things I want to say about the question itself. First of all, I want you to circle the word closest, because this is going to tell you that whatever answer you get is not going to be in the answer choices. You have to round. So that's the first thing, because I don't want you freaking out because your answer isn't in the choices. So you realize, okay, I'm going to round it when I'm done. They're asking us for the average, and they don't give us a list. So we have to create a list based on this bar graph here. So because our focus is on the number of seeds, we're writing down the number of seeds. And this is going to tell us the frequency of how often that number of seeds appears. So in this first bar here, we've got 3 seeds, and it appears in 2 apples. So we have 3 seeds in 2 apples, so we write 3 down twice. Our second bar is 5 seeds, and that goes up to 4. So we have 5 seeds appearing 4 times. in 4 different apples. We keep going like that. So we have 6 seeds appearing just once, and we have 7 seeds appearing, looks like twice. So we have 7 seeds appearing twice. And then finally we have 9 seeds, and that looks like it's appearing 3 times. So we end up with our nice list of numbers. And then we add them up like we do for every average. If we add them up, we get a 73, and we divide by the number of numbers. Now we can count up all these numbers, or we can just look at the title. It tells us there are 12 apples, so the number of numbers is 12. 73 divided by 12 is 6, plus a little extra. I don't happen to have my calculator with me, but I know that 12 times 6 is 72. So there's just going to be a remainder of 1. So it's just going to be over 6, barely. So the closest number, the closest to the average number of seeds is going to be 6. All right. Now, our next number is going to be number 14. So just flip the page. Okay, it's the same test, same section. And we have got a big table of numbers. Oh my goodness. And I hate to say it, but I actually need to fill in all of these numbers. So if you'll give me a moment, 3, 4, 5. Okay, I need to fill in these numbers so that we can fully work through all the problems. But if you look at the answers first, you can see that you need to know something about mean, median, and range. Okay, and so we can go from there. All right, I'm going to take a minute away from filling the stuff in, and let's read the question. The table above lists the lengths to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. Of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data? All right, so first of all, it says which will change the most. I want you to circle the most. All right, now I need to fill in the rest of these numbers so we can do the problem. Okay, on 13. All right, good. So let's start with the median. I think the median is going to be the easiest one. The median is the middle number, and as you can see, these numbers are already in numerical order. So they've done that work for us. And if we just eyeball it, we can see the median smack in the middle is 12. Now, they are also saying that this 24 is an error, and they want to remove that. But even if we remove it, on either side of this 12 are more 12s, and even another 12 over here. So our median is going to remain 12, whether we take out that 24 or not. So since they're asking us for what changes the most, we can get rid of the median because that's not changing at all. Now let's go to the mean. The mean is the average. Now you can take the average, you can add up all of these numbers and take the average, divide it by 21, and then get rid of the 24 and add up all the rest of the numbers and divide it by 20 and see how much it changes. And that's fine to do. However, I want to show you a shortcut, and it involves a little bit of logic. Now, we've got 21 numbers here, and we're going to get rid of a 24. So remember that how can I say this? The 24 is going to change the top, right? So you have the sum on the top, and then the number of numbers on the bottom. Well, this is going to just go down by 24, and this is going to go down by 1. It's not going to make that much of a difference? Because there are 21 numbers, and 24 over 21 is just a very small number. Now, if you're not quite getting what I'm saying, it's okay. You can just add all these up and do the average like that. It won't actually take you that long. But what I'm trying to get at is the bottom number is going to go from 21 to 20. The top is going to go from sum x to x minus the 24. You're going to get rid of that 24. And there's not really that much difference because the denominators are so high and they're so close to that 24. Anyway, what I'm saying is the median will change, but it won't change very significantly. So out goes mean, or A. Now, if we look at, and we can get rid of D, D just says they'll all change by the same amount. But we know that's not true because median won't change and mean will change a little. If we look at the range, which is the difference between the biggest and the smallest numbers, with the 24, our range is 16. If we get rid of the 24, our biggest number is 16. And if we subtract out our smallest number, it's 8. That is going to be the biggest difference that we have. Everything else either stays the same here, like the median, or just changes a little bit, like the mean. Our answer is C, or range. Okay, now there is another way. I'm going to clear this out. And now I'm going to just give you a random sampling of questions here. They're not a part of a test. But this has to do with another way they can present the mean or the average. And it might be something like A equals the average of x plus 9. All right, and then you write that out. X plus 9 divided by 2. Then they might say B is the average of x minus 7. And again, you divide it by 2. And they might say C is the average of 3x plus 1. And you divide it by 2. And then the question asks for the average of A, B, and C. So we're simply adding up all of the numerators. Yeah. So we have x plus 3x. That's 5x. We've got 9 minus 7, which is 2, plus 1, which is 3. Now the question is, since we're going for average, so we have to divide it by something. You might think that we would continue to divide it by 2, but we actually added up all of these numbers, all of these 6 numbers, so we should be dividing it by 6, and that would be your answer. Okay, so a somewhat important point. Let me talk to you about another question. And actually, this question is on a test. Test 2, you can go here right now. Test 2, section 4, number 18. And this looks like a word problem. I mean, it is a word problem, actually. But it involves mean and median. So it says a survey was taken of the value of homes in a county. And it was found that the mean home value was 165, and the 165,000, and the median home value was 125,000. And so what I would do is I would just write that down right now. So we've got the mean of 165, we've got the median of 125. I always like to write things down so I don't have to go back and read from the problem itself. I'd rather read my own handwriting. Now the question is, which of the following situations could explain the difference between the mean and the median home values in the county? So I like to write this out on a kind of number line, I think. So The median is the middle. So let's just put that right in the middle. It's 125,000. Now the mean is, let's say it's up here. It's 165,000, clearly higher. Okay, so this is the median. That's the middle. And this is the mean, which is the average. All right, now I think we need to just look at the answers. A says, so remember, we're looking for the reason for why these are different. A says the homes have values that are close to each other. How is that an explanation? That doesn't explain why they're different. That would explain why they would be close, and they're not close. So A makes no sense. We can just cross that out. Now B says there are a few homes that are valued much less than the rest. Now let's just take this and get into what this means. The middle is, well, it's the middle. That means there are the same number of homes on this side as there are on this side. Now, it doesn't tell us anything about what the values are of those homes. But let's look at the mean. Now, the average is, remember, we're adding up all the values and then dividing it by the number of values. So if this is the middle, in order for the average to be this much higher, we need to have a bunch of houses that are definitely higher in value, right? We need to have, let's say, homes that are $200,000 worth. Okay. This is so funny. To me, I live in Santa Cruz, and this is like a down payment for a house here. Okay. Anyway, so the fact that B says there are homes that are valued much less than the rest would not be an explanation for why the average is higher. So that doesn't work. C actually says there are a few homes that are valued much more than the rest, and that's really what we just talked about. C is our answer. And then if we look at D, D says many of the homes have values between 125 and 165, which doesn't account for the average being at 165, which means that there would have to be more expensive homes. So D also is out. Okay, so that is that. Now, there's one other kind of question that I think I'd like to go over with you. I'm going to clear this off. All right. Now, this is a kind of question that is a word problem that involves averages. Okay, so it might be like there are 8 players in a basketball game, and the mean score or the average score of those 8 players was 14.5 points. Now, they're not telling us each player's score, right? They're telling us the total average. So we don't have a list. So instead of working with the individual scores, we have to work with the totals that they give us. So if we do 14.5 times 8, we're going to get the total. And that total is 116. Okay, now we're going to continue reading the question. If the highest individual score is removed, the mean score of the remaining 7 players, so I write 7 players, and the mean score is 12 points. So we're going to do exactly the same thing here. We're going to take 12 points and multiply it by the number of players, and we've got 84. So this was with, and they're asking us for the highest score, right? And that highest score, remember, has been removed, right? So what we want to do is we want to take that 116 when all 8 players were included, and we want to get rid of the 84, which is the number, the total, when there were only 7 players, right, after that highest score was removed. And then we get 32. And this is going to account for the score that was removed. Okay, so the answer is 32. All right, my friends, that's what I've got for mean, median, mode. Take it to heart, learn all those terms, and you'll do great. Okay, thanks. Bye.